Edison Research gathered exit poll results from several sources for the Wisconsin recall election of Scott Walker. They found that 53% of the respondents voted in favor of Scott Walker. So that's going to give me one of the branches of a tree diagram. This is a Bayes' theorem question, and I'm going to use a tree diagram to solve it. It says, additionally, they estimated that of those who voted in favor of Scott Walker, 34% had college degrees. So that's the probability of having a college degree given that we already know you voted for Scott Walker. While 42% of those who voted against Scott Walker had college degrees. That's the probability of having a college degree given that you voted against Scott Walker. It says, suppose we randomly sample a person who participated in the exit poll and found that he had a college degree. What is the probability that he voted for Scott Walker? So that's find the probability that somebody voted for Scott Walker given that they had a college degree. So here's some information that's given. They're giving us the probability that somebody voted for Scott Walker. I'll abbreviate that, the probability of V, or the probability of voted for Scott Walker. They gave that as 53%. Now by default, that means that the probability of not V, or the probability of not having voted for Scott Walker, has to be the complement, 1 minus that number, which is 47%. 47%. Those have to be complements. And that's the first branch of your tree. The first branch of your tree has those who voted for Scott Walker and those who did not vote for Scott Walker. All right, now for the second branch of your tree, or the second pair of branches, we are going to have conditional probabilities. So in this case, we already know that these people on this top branch voted for Scott Walker. So of those people that voted for Scott Walker, we already know that fact, 34% of them had college degrees. So that's the probability of voting for Scott Walker, or the probability of having a college degree, given that we already know you voted for Scott Walker. And that probability was given as 34%. That's the probability of having a college degree given that you voted for Scott Walker. The alternative is having or not having a college degree given that you voted for Scott Walker. So on the voted for Scott Walker branch, we have the people with degrees and the people without degrees, and they have to be complements. They're exhaustive. You either have a degree or you don't have a degree. There's no other choice. So that represents a complement, which is 1 minus 0.34, or 0.66, 66%. 66%. Okay, so there we have that first one. Now let's look at the second one here, the second branch, for all the people that did not vote for Scott Walker. So it says, of the people who did not vote or voted against Scott Walker, 42% of those people had college degrees. So the probability of having a college degree, given that you did not vote for Scott Walker, is 42%, 0.42. And once again, these branches of these trees have to be complements of each other. So if 42% of the people who did not vote for Scott Walker had college degrees, by default, the complement, or 58% of the people that did not vote for Scott Walker, did not have college degrees. So 42% did have college degrees. That means 58% did not have college degrees. All right, now the last column in this table would be reserved now for the joint probabilities. And the joint probabilities are just the product of the marginal probability and the conditional probability. So for instance, if I wanted a joint probability of somebody that voted for Scott Walker and had a college degree, I would just multiply these two, 0.53 and 0.34, because that's what that's equal to. The probability of V and D is equal to the probability of V times the probability of D given V. That's the definition of the joint probability, and. So that's just going to be 0.34 times 0.53, which is 0.1802. So 0.1802. And then the next one is also going to be the product. So the probability of voting for Scott Walker and not having a degree is equal to this product, 0.66 times 0.53, and that's 0.3498. So 0.3498. And then the next one is the probability of not having voted for Scott Walker given that you had a college degree, and that's the product of these two, 0.42 and 0.47, which is 0.1974, 0.1974. And lastly, but not leastly, we have the probability of not having voted for Scott Walker given that you do not have a college degree. And that's equal to this product here of the conditional and the marginal, and that's going to be equal to 0.2726. 0.2726. Okay, now, none of that gives us the probability we actually wanted, because the probability we actually wanted is the probability that somebody voted for Scott Walker given that we know that they had a college degree. So found that the person had a college degree, so we know that they had a college degree. We're asking what is the probability that they voted for Scott Walker. So that's the probability of voted for him given that they had a college degree. Okay, I'm going to use the definition because the definition is what leads to Bayes' theorem. By definition, this probability is equal to the probability of V and D divided by the probability of D. That's the definition. And we have part of this. We have the probability of V and D is the first one we found up here. Probability of V and D, 0.1802, the first joint probability we found. What we need is the probability of D. But we're going to use the information that the probability of D we can get by looking at the people who had degrees and voted for Scott Walker and the people who had degrees and didn't vote for Scott Walker, because those two things actually add up to the total probability that somebody had a degree. So these two numbers right here add up to the probability that somebody had a degree, because it turns out that the probability of D, the total probability of D, is the probability of D and voted for Scott Walker plus the probability of D and did not vote for Scott Walker. Because that's everybody, those who did and those who did not vote for Scott Walker. And we have the college degrees amongst both groups. Okay, so now I can find all this information. That's 0.1802 on top, 0.1802 divided by, and on the bottom is 0.1802, which is that same probability, plus 0.1974, which is that other probability, and this is equal to 1802 over 3776, which is 0.4772. And that's the probability we're looking for. We're looking for the probability of V given D, and that's equal to this. Okay, now how do you recognize that you're using Bayes' theorem? Well, I knew because, I made the problem or whatever, but you can tell because if you notice, they gave us right away the probability of V, and then they gave us the probability of D given V. So if you write it out, you see that they give you the probability of D given V, and then ask you for the probability of V given D, which is the inverted probability. That's how you recognize a Bayes' theorem problem. They give you one conditional probability, D given V in this case, and ask you to find the inverted probability of V given D.